All right, hello. This is day 2 from chapter 11, sequences and series. And so we talked about arithmetic sequences, and now this is what arithmetic series is. And a series in general is just the sum of n terms, and n terms is just saying n amount of terms of an arithmetic sequence. There are two different formulas. They are actually the same. The first one says n being up front, and then you'd have your first term and your last term that you're counting to on top being added, divided by 2. Or you could put the divide by 2 out in front with the n, and then just have in parentheses a1 plus an. They are effectively doing the same thing. And n is the number of terms being added together. So that's kind of a difference. We have a sub n, meaning the last term or the nth term that you're adding to, or that you're talking about, where you want to stop adding your sequence together. And s sub n is saying what's the sum of all those terms. But n is the term we're talking about. So find the sum of the first 32 terms in the arithmetic series. And it goes like this: -12 plus -6 plus 0. And just so we're clear, this is a series because each term is being added together. A sequence that looks the same would just have commas because we're just listing off the terms of a sequence. But since we're in series right now, we're adding together. We know that a sub 1 is -12. We know that a sub n is 174, and we were given that these are the first 32 terms, so n is 32. Notice we don't need to know what the common difference is. Surely we could find it. It looks like it's +6, but it doesn't really matter. All we need is we're finding s sub 32, because that's what n is, and I'll just use the first formula. N times a sub 1 is -12 plus 174 is our a sub n, a sub 32, right there, and then we divide by 2. Okay, and so into calculator we go. -12 plus 174 is 162, divided by 2 is 81, and we have n, forgot to put that in, is 32. So ultimately this goes, if you put this parentheses into calculator, you'd get 32 up front times 81. And 32 times 81 is 2592. Now it looks like that escalated really quickly. Like we had a big number and we're only adding up these smaller numbers. For instance, our fourth term is only 6, or third term is 0. We're adding up these numbers, but we keep on adding up each next term, and it accumulates pretty quickly. We get 2592. Here's another example that maybe we're missing different pieces of information. So we're going to find a sub 1 now, but we know a sub 30, or s sub 30, sum of the first 30 terms, and we know the 30th term. Therefore, we also know what term we're talking about. We're talking about the 30th term. And so we could fill this in. Again, here's the formula. So this is s sub 30, 39, 21, 30. A sub 1 we don't know, plus a sub 30 is 160 over 2. There's a couple things we could do. I might opt to say, well, I like this formula better at this point, and here's why. Because if this is 30 over 2 up front instead, I'm essentially just saying, well, I want this to have the 2 and not this. That's fine. We end up with 15, and one thing is already simplified. And then at that point, I see that a sub 1 is stuck in parentheses, I could subtract the 160, but not yet because there's a 15 multiplying outside of it. So we need to get rid of that 15. Let's do that. Divide by 15. 3921 divided by 15. And we get 261.4. This is a sub 1 plus 160. And we would just, at this point, subtract 160. So 101.4 equals a sub 1. And we want to be wary when we get decimals, only in the sense that if we're solving for n and we get a decimal, that's not good, because there's not going to be a spot in the sequence that has a decimal. We're talking about spots in the sequence should usually have always have whole numbers, like first spot, second spot, third spot. All right, the next one says find a sub 1 if s sub 64 equals 704 and d is 12.8. This is asking us something a little different. We haven't seen d in any of these formulas, so how are we going to find the series? How are we going to use the series formula? But since I'm talking about n is 64, and I need, when I'm using the series formula, I need a sub n. So real quickly, I'm going to write another formula down here. Let's see this thing. Basically, where that comes from is, let's say we had s sub n equals n over 2 a sub 1 plus a sub n. Now notice, in this problem, we have a sub 1, we don't know it. We also have a sub n, we don't know it. But I do know that a sub n is equal to a sub 1 plus d times n minus 1. And I do know most of this stuff. I know d and n, don't know a sub 1, but I could substitute this chunk in for a sub n because it's equal to a sub n. If I did that, I would essentially be ending up with this formula. We can go ahead and try it. This is n over 2. I have a sub 1 plus a sub 1, so it's 2a sub 1, and then plus d n minus 1. So it's basically just combining things, and we can use this when we need to. But I wrote it already right here. This is a good formula to also have. So right now, this says s sub 64 is 704 equals n, which is 64, over 2, times 2 a sub 1. We don't know a sub 1, but we do know d, 12.8, and we know n minus 1. N is 64 minus 1. So we'll want to piece this together a little bit. We can start on the inside if we like. This is 64 minus 1 is 63. And 12.8 times 63 is 806.4. 2 a sub 1 plus 806.4. Parentheses, this, if I divided that, would be 32. 704. Okay. At this point, a sub 1 stuck inside parentheses. Let's get rid of that 32 first. 704 divided by 32. It's 22. 2 a sub 1 plus 806.4. And now we can solve the rest. We're going to subtract 806.4. Minus 806.4. 80784.4. And the last step, divide by 2, because there's a 2 in front of the a sub 1. Negative 784.4 divided by 2. Negative 392.2. is a sub 1. So that would be our starting number if we started adding up all the numbers in this sequence from the first term to the 64th term, and we ended up at 704 if the common difference was 12.8. That's what we found. Whew. All right. Here's a word problem. These could be complicated, but let's just write down everything we know. Right side of the orchestra section of the Nederlander Theater in New York City has to replace the seats to accommodate more people. If the first row can only fit 25 and each additional row can have 2 more seats in it, how many rows will it take to have a seating capacity of 1377 people for that section? So how many total rows? Right now, we know we want the total seating capacity, S sub n, to be 1377. We don't know what n is, but we have to add. If we added all up all the seats, we'd have that. We know that the first row, A sub 1, first term in our sequence of rows, it's like 25 here, and then 1 more seat on each end, 1 more seat on each end, 1 more seat on each end. We're basically adding that for each next number. So we have 25, and then A sub 2, we're going to add 2 more rows, would be 27, and so on. We know that D then is going to be 2. We're adding 2 each time. But we don't know how many rows it's going to take to get to a total of all of these seats to be 1377. So we don't know A sub n, again. So I'm going to use that same formula we just had. It's right there. Fill in what we got. We know that S sub n is 1377 equals n we don't know. So we might have to work backwards in a second here. N is divided by 2, and then 2 times A sub 1 is 25, plus D. We know that D is the differences in each row is adding 2 seats, so 2. And then times N, again, we don't know. That's how many rows, minus 1. Okay. Well, let's see what we can do. First of all, we can simplify. This is going to be 50. I can't do much with this thing. I can distribute it if I want. Let's try that, maybe. This would be 50 over there plus 2n minus 2, and we can simplify this. So in parentheses so far we would have 2n plus 48. I wrote the 2n first. Still have n over 2 over here, and instead of distributing a half to each of this, which I certainly could, I could double the other side, multiply it by 2, or distribute a half. So basically I'm just saying I'm going to distribute this guy across. I'm going to get 2n times n over 2. The n's are going to square now, but the half and the 2 will cancel each other out. So n squared. N over 2 plus 48. 48 would be cut in half, 24, but now it has an n. And I'm left with this. Now this is unprecedented for what we've been seeing, but no matter, it's a quadratic. We need to get everything on the same side to solve a quadratic. And now it's equal to 0, and we can solve it. We could guess and check. We could use quadratic formula, but since I have Desmos open, I'm going to solve it by graphing. N squared plus 24n minus 1377. Okay, and it wants me to add a slider. I'll change it to x, maybe like it better. All right, equals 0. Does it give us anything? Let's go way out. Okay, we see where it crosses the x-axis. Looks like right there, negative 51 and 27. Negative 51 and 27. So let's write what we have. Negative 51 equals n and 27 equals n. Well, certainly we're not going to have something that is a negative rows. There's no such thing as having a negative amount of a physical object that's in front of you. So that can't work, but 27 can. So that means that it would take us 27 rows, adding 2 seats per row, starting at 25 to end up at 1,377. So n equals 27 rows. So when we solve for n in a arithmetic series formula, we will end up having to solve a quadratic, but just put in Desmos and find the zeros. All right, hope this helps. Good luck.